So a maintenance, an equipment is a maintenance 1 p.m. Until 29, it will run the process. Maybe until 12:30, it will run the process. Consider that equipment's process takes 25 minutes or 35 minutes. So at 12:30, the next process will take 35 minutes. So I can't go through this because at one something is going to happen. So this equipment will go down. This is called as equipment state. So an equipment, whether is it up, is it running, is it down? So there is 3 main states. The first state is up. It is available. So it's available to run the process. This equipment is currently available for you to come and run the process. The second is running state. The down can be categorized into 2. That's where the maintenance management comes. The first downtime is the preventive downtime, where during the maintenance process, the machine shuts down automatically. The second is obvious thing, which is unexpected outcome. So that's where we have another system called as OCAP. Out of control action plan. So some things happen. We can't predict that this equipment is going to go down, or even a durable or a consumable. I'm getting the durable from a third party. He says that this durable is valid for 5 years, but it might run off in a year or 6 months even, which is which is unimaginable for me. So that is called as out of control. That is out of control. I can't plan for that. So for that, we'll have an action plan. For every part in an equipment, for every scenario in an equipment to go wrong, we'll have an action plan. When this goes down, what should happen? When this goes down, what should happen? When this goes down, what should happen, and so on. So this is called as OCAP. Okay. So this is the 5th one. The 6th one is alarm management. So when an equipment goes down, so every equipment, I think even in this packing flow here, you see this traffic signal like red, yellow, and green. Yeah. So when something happens, because so every equipment going deeper. Okay. I'll say this and I'll move on to the next topic and going deeper into the topics. So every equipment has a spec limits. You guys know what is a spec limit? No, operating thresholds. Yes. So if so OCAP tracks that spec limit. So let's say for an equipment is running a process, and it is every equipment gets heated up, right? So if you're riding a bike, your silencer gets heated up. So similarly, I'm just giving you an example. This is not the actual case. If the process is happening, the temperature should only go about 1 or 2 degrees Celsius. The tolerance level, exactly. That is called as, here we call it as spec limits. Okay. We have an upper spec limit and we have a lower spec limit. So it should not go above upper spec limit, or it should not go below lower spec limit. So we have a spec limit and before the equipment goes down limit. Yes. So what OCAP does is it plots a graph. Consider this is 0, this is +5, this is -5, this is +10, this is -10. No equipment is perfect in its case. So, okay, there is also another case. Consider everyone has you guys are familiar with pressure cookers, right? When you buy the cooker during a new stage or the pressure cooker, let's go back to the car example. When you buy a new car, the first 10 days or first 2 years, the mileage will be excellent. Yes. After that, your mileage will decrease gradually. Yes? Yes, sir. But consider you decided to go to Chennai to Bangalore in your first 2 years. What you will do is I'll top up 2,000 rupees for petrol. I'll know it will cover me 400 kilometers because I know my car mileage is 20 at this stage. But after 2 years, I know my mileage is dropping. Now it is only giving me 15. So I'll top up for 3,000 kilometers. So similarly, the spec limit will also get adjusted based on this one. So as and when the time goes on, the equipment's performance degrades. Obviously, any equipment, anything you buy, because it's a machine, it needs maintenance and so on and everything. Anything you buy, it needs certain time to complete that process. So in semiconductor terms, consider the wafer is going through the process. It's going to consider furnace monitoring. I'll give you an example of furnace system. Previously, I need to heat up the wafer at 100 degrees Celsius. Now, since the equipment is kind of old, it is not heating up as usual. So now I'm going to heat it up to 102 degrees Celsius. Okay. So this should happen. So maybe 100 degrees Celsius previously it was for 5 minutes. Now I can upgrade it for 6 minutes. This everything is monitored by OCAP. So when a process degrades, there will be an up and down cycle or a lower cycle or so on. But if it goes to any of near the spec limits, so this is an acceptable range. If it is +4 or -5, no problem for me. I'm fine. What OCAP does is here, if it goes beyond this one, that's where OCAP triggers out of control. It's going out of control. I need an action plan now. So either it is due for maintenance. I might have skipped maintenance. That might have happened. I might have skipped maintenance. That's why this equipment is overheating or taking more time to complete. So what I'll do is maybe I'll go for maintenance and come back to this equipment. At that time, it might come down. So whatever may be the action plan, it goes out of control. I need to do something. So that site engineer, or what is he called as? Customer engineer. The one who is in the spot will understand this one and he takes an action plan. So I'm saying this in a manual process, but in an automated process for every scenario, everything is recorded. When something like this happened, do this. When something like this happened, do this. When something like this happened, do this. So once the action plan is carried out, it again notices the graph. If the graph is within this limit, it is fine for. If the graph goes over the spec limit, this is called as the danger limit. It goes over the spec limit. Now nothing can be done. That's when the alarm management system comes. So here, until or otherwise it is in control, it will start blaring. It will give the sound to indicate there is something wrong with this equipment. Do something right away, or your okay. Another term comes in. When a wafer is put in a machine and it is getting processed, it is called as a lot. LOT. It's a digital term. There is no physical meaning for a lot. A lot is a digital term, generally called as 25 wafers. 25 wafers. So typical FOOP has 25 slots. A lot can have 25 wafers, 20 wafers based on the process. For example, a customer comes in and asks for 104 wafers. The first lot will have 25, the second lot will have 25, the third lot will have 25, the fourth lot will have 25. But the fifth lot cannot have 25 because for that customer's needs, I only need 104. The last lot may have 4 wafers. A lot, why a lot digital term is required is a lot goes through a series of process. So when a lot comes in, it goes through a series of process for the customer's recipe. So I'm going to manufacture, I need 104 wafers. So each wafer gives around, based on the number of size of the chips, it gives around 70 to 80 chips. So I'm going to need 8,000 chips. So I don't need 125 wafers. At that time, I might need 120 wafers. So a lot can have only maximum of 25 wafers because the FOOP is only capable of holding 25 wafers. So after the fourth one, I'm only going to need for this process, I'm only going to need 20 wafers. At that time, a lot will have only 20 wafers. So that is, there will be a lot of confusion. Again, there is a lot. There will be a lot of confusion in this one. Please don't take anything to mind because until even the experienced person get confused on this, lot is not a physical term. It's just a digital term.
Can we say something like lot is a process where all number of wafers?
No,
I didn't complete.
No, I understand your question, but that is so. 104 wafers comes in. Not 104 is not called a lot.
Okay.
Why? Is because when a lot goes through a system, actually a lot is one category traveling together. When a lot goes through a system, say for example, 25 wafers are traveling together. So 100 wafers are traveling together. Let's say the second set gets failed, the second lot gets failed. Only the second lot will repeat the process, not all the lots will repeat the process.
You mean the second FOOP, not the second lot? In one lot, we have 4.
No, that's not, that's the one I'm mentioning. Not everything together is called a lot.
Okay.
Every FOOP which undergoes a particular process is a lot.
Same process.
Same process. Because
so you mean to say there are 4 FOOP, so we'll call it the 4 lots.
4 lots, yes. Not as a single lot. Even if the 4 FOOPs goes through a similar process until the end result, it is not a single lot. It is 4 different lots because anything can happen at any phase that particular set has to go through the process of any of the process to be repeated or any.
Only that particular FOOP will go to that particular.
Yes, correct.
It's not the name.
10, exactly.
But there also I see a problem, right? If there are like 10 wafers and fifth wafer is having a problem, 4 wafers have been done. So we have to start the process again for fifth, sixth and other wafers, right? Not for the first 4 wafers.
That's correct. So at this point, what happens is this lot waits until this wafer goes and completes all the other process.
The rest of the wafer.
Yes.
So within 25, we may have the rework for the 5 wafer.
Yes, but there is also a possibility this might have happened at 999th step. That can go, that has to go through a number of processes. That might become a new lot.
Okay.
Because
Now
now,
going all the way for entire path.
yes,
So that will come.
yes,
So basically, when go like an issue with, let's say, one wafer out of one lot. So when it goes through the entire process again, then that means the all the wafers, all the okay,
so okay, so when a wafer goes through a particular process, consider one wafer gets failed, the wafer creates a new lot or goes into another process. This lot will ignore that wafer. So this will go through this process continuously. But if the process gets failed, there will be an action plan for this lot, and then this will travel together.
All 25 will travel together, but the process will
When the process fails for all 25 lots, so something has happened with the equipment. So the scenario for only one wafer failing in a lot is very low because there is something called as test wafer. Again, that is another huge topic. I don't want to go into that. I'll go into the remaining systems. If time permits in the upcoming days, I'll cover those. Right. Okay.
One question. You said it's only digital, but how do you confirm that if the second one is failed? You need to some instantiation, you need to do it on the task, right?
Okay. So in the digital term, even though it is a digital term, the FOOP, right? So if a lot is traveling in a FOOP, they won't change the FOOP. If okay, the FOOP is a front open unified form. Elsewhere, this is an equipment. This has a front opening like this. This is called as a port in an equipment. I'm going to lock my FOOP here. So this will carry out my process inside this wafer. So an equipment will have chambers. So from my FOOP, the wafers will be taken out, put it into the chambers, the process will get completed and placed inside the same FOOP and move on to the next process.
So the entire 2 will be